Hey guys, this is the recording for 7.3 trigonometric equations. Okay, so example 1, solve for each interval, solve each on the interval from 0 to 2 pi non-inclusive at 2 pi. So what that means is that I'm solving for one full revolution or one full period. Okay, so I'm just going to do all the algebraic stuff normally. So here we go. X plus 1. So plus 1 to both sides. Why did I write equal? Okay. So plus 1 to both sides. So now I have 2 cosine of 2 theta equals 1. Now before you start, you might want two things. Find the period of each equation. So period of cosine is always 2 pi divided by absolute value of b. B is this thing right here. Let me just get an orange. B is this value, okay? This right here, this number 2. So when I go 2 pi divided by 2 absolute value, my period is a pi. And this will come in very, very handy. It's not an answer that I'm looking for. I'm solving for theta, but that's the period, okay? So that's one thing that you need to focus on. Another thing is this restriction. Whenever you're solving and this restriction is not here, that means, just like in Algebra 2 trig, using your K stuff, okay? But if the restriction is given to you, then this is when you have to list out all of the answers, okay? All right, so let's continue on solving. Now I'm going to divide everything by 2. So cosine of 2 theta equals 1/2. Now I will compose both sides, so theta equals cosine inverse of 1/2. Okay. Even though we are using cosine inverse to solve, we're borrowing. Okay, I'm going to use the word borrow. We borrow cosine inverse to solve, but the original, okay, let's go back to the original, is not an inverse function. Because it is not an inverse function, there's no restrictions, okay? There is no restrictions, okay? Due to the fact that the regular equation is a regular trig, not an inverse, okay? We are just borrowing an inverse right here to solve, okay? So cosine of 2 theta equals positive half, which is equivalent to 2 theta equals cosine inverse of 1/2. Because we are borrowing to solve, that means I can be anywhere. There's no restriction. Keep that in mind. Cosine is positive in quad 1 and quad 4. Okay, cosine is positive in quad 1 and quad 4. What that means is I'm going to have 2 different answers here, 2 different quads. Okay. But I might have multiple solutions depending on my period. So from here, I'm going to go, 2 theta can be in quad 1, okay, which is this angle. Well, if that's the angle, that's really pi over 3. Or, okay, 2 theta can be in this one. And it's from 0 to 2 pi, so I can't really have negative. I have to go positive revolution. So that can be, what do you think that is? What is this angle in quad 4? Okay, so we have figured this is already pi over 3. What is this one? Did you say 5 pi over 3? All right, way to go. Okay, then from here, I will now get rid of the 2 by multiplying by 1/2 or divide by 2. However you want to think of it. Okay, divide by 1/2 times 1/2. I'm sorry, divide by 2 or times 1/2. That's what I meant to say. So 1 theta is really what I'm trying to solve. It's pi over 6. Okay, we're over here. 1 theta is 5 pi over 6. But keep in mind, I am trying to get all the way to 2 pi. So this is when the period is going to come in. Okay, you need to add a period. Okay, you need to add a period. So pi over 6, we have to keep that, but what if I keep on going, right? So if I get to pi over 6 plus a pi, is that still within 2 pi, from 0 to 2 pi. Well, pi is really 6 over 6, okay? So this is, think of it as pi over 6 plus 6 pi over 6, okay? Well, this is now 7 pi over 6. Well, that's still less than 2 pi. I can totally have that, okay? How about over here? Same thing. Theta equals 5 pi over 6 plus 6 pi over 6. So this is now 11 pi over 6. I can definitely have that. It's still less than 2 pi. Remember, 2 pi with denominator of 6 is really 12 over 6, okay? So these are all 4 that I'm supposed to have. So here we go. Theta equals pi over 6 and 5 pi over 6 and 7 pi over 6 and 11 pi over 6. And box that up. And yes, you have to have all 4 solutions to have full credit, okay? All right, let's do tangent. Tangent, we're starting out with the normal tangent. That means no restrictions, okay? No restrictions. Even though later we might borrow an inverse to solve, but we always have to look back at our original. The next thing I'm going to do is I'm going to find the period for tangent, okay? Period for tangent is always pi divided by absolute value of b. b is this 3 right here. So now I'm going to go and go, pi divided by absolute value of 3 is really pi over 3. I'm going to keep that on the side. And here I'm just going to solve for this normally. So here we go. Move the 1 over. Radical 3 times tangent of 3 theta equals negative 1 divided by rad 3 divided by rad 3. Tangent of 3 theta equals negative 1 over rad 3. I don't have to rationalize this because this is really not my final destination, okay? But I know that tangent is negative in 2 places, okay? It has to be in quad 2 and it has to be in quad number 4. So what is this angle? That's one question. And quad 4 is this one. So what is this angle? Okay, so that's what I'm trying to find. Well, but I'm not solving for tangent of 3 theta. I need to keep on going. So I need to compose. 3 theta equals tangent inverse of negative 1 over rad 3. This is where the unit circle is going to come in handy. So something that's 1 over rad 3, and this is negative. A negative really tells me the quadrant, 2 and 4, okay? So negative 1 over rad 3, it has to be multiples of what degree? Or I'm sorry, I should say radians. What radians? So you can have 2 answers. Okay. 3 theta, it's either at, or 3 theta, it's either at. So you tell me. What angle should we write down in radians? It's multiple pi over 6, but I'm in quad 2, so that would be 5 pi over 6, okay? And in quad 4, it's 11 pi over 6, okay? All right, now I have to solve for 3 theta. I have to solve for 1 theta. You're not keeping 3 theta. So I can divide both sides by 3 or times 1/3. Divided by 3 or times 1/3. Okay. So 1 theta, this is really the beginning, which is 5 pi over 18. Yeah, that's one answer I can totally keep. And over here, 1 theta, it's 11 pi over 18. Okay, that's another one I can keep because it's still within 0 to 2 pi. Now, let's look at the period. The period is pi over 3. With denominator of 18, that's like multiplying this by 6 and that by 6. So that's really 6 pi over 18 that I need to keep adding, okay, until I get to somewhere near 2 pi. Well, 2 pi with denominator of 18 is like 36 pi, okay? So this is where I could end near 36 over 18 pi. So what if I keep adding the period, which is pi over 3, which is aka 6 pi over 18? What would be my next angle that I could repeat? Remember, I'm just going around this multiple times, okay? So this is 11 pi over 18. That is another angle I can keep. How about over here to the right? Add 6 pi over 18. It's just a period with a common denominator. So that's now 17 pi over 18. Can I keep going? Of course. Let's keep on going. Okay? Remember, you need to stop at 36 pi over 18. So this is 6 pi over 18. All right, here we go. Theta equals, that's 17 pi over 18. You're going to see something funny. And then I'm hoping you're kind of thinking and kind of telling me what's going on, okay? This is now, keep on adding. So here we go. Theta equals 23 pi over 18. Keep on going. Are you ready? Keep on adding, because it's not anywhere near 36 pi over 18 yet. Okay? Keep on going. All right, so I now have 23 pi. Do you see something funny yet? Okay. And then, now to the right, keep on adding a full period. Okay, so theta equals 29 pi over 18. And then, if I keep adding, okay, as you get the pattern, if I add 6 pi over 18, I now have 29 pi over 18. Do you see something funny at all? I hope you are. Plus 6 pi over 18 some more. So theta equals 35 pi. Oh man, okay. 35 pi is the closest that you're going to go without going over. All right, so check this out. What is going on? These two are the same. These two are the same. These two are the same. What? These two are the same. Okay, so what's happening? What is happening is that because tangent and cotangent, okay, a period, because they are directly across from one another, okay, because they are directly across from one another, see how it's an equal distance? Can you see this? From here to here, it's an equal distance as is from here to here. Okay, so I'm going to repeat that. On the top and on the bottom, they are exactly the same. So in theory, okay, in theory, I do not, okay, I'm going to repeat, I do not have to, okay, I do not have to use both points. I do not have to use both points to find all answers. I can just use one of the points and find all of my answers. Okay, so if I keep on adding, okay, if I keep adding, then notice how like all of this right here is going to keep on, and then the last one I can add another 6 pi over 18 to get my last answer. That's before 36, which is really 35 pi over 18. Okay, so when you can see that it's an equal distance, you don't have to use all of the points to find all of the solution on the list, okay? You can just use one point, even only if it's equal distance, okay? And then that's just as good. Now in letter A, the distance from this right here, okay, to here is not equal to the distance from here to here. So you have to use both points. But on B, the distance from one to the other are identical. So in theory, you only need to use one of them. So the answer for theta is, let me just write it down and then box it up. Ready? 5 pi over 6, I'm sorry, 5 pi over 18, comma, 11 pi over 18, 17 pi over 18, 23 pi over 18, 29 pi over 18, and last one, 35 pi over 18. And box that up is my final answer. Okay. All right, this is where I'm going to stop. I will see you tomorrow and have a wonderful day.